Now on the right, we've got what we know about sine, cosine and tangent, in that sine starts off at 0 and heads towards 1, and cosine starts at 1 and heads down to 0 as we move the hand from 3 o'clock to 12 o'clock. But we've got no idea what the shape of the curve is. I'm going to move theta upwards up to 90. I'll do it slowly. So here we go. I'm starting to move. So the triangle is beginning to form. Sine theta is climbing up and cosine theta is falling. You can see sine is climbing very quickly and cosine's only just beginning to start falling reasonably quickly as well, but it stayed at 1 for some time. They're approaching the same value. Well, we know where that's going to be. It's going to be at 45 degrees. And there we are. The triangle that's formed is an isosceles triangle with 45 degrees in both of the corners and a right angle at the bottom. And the lengths of cosine theta and sine theta are equal. So what's going to happen as I advance the hand even more towards 12 o'clock? Well, sine is continuing to climb and cosine continuing to decrease in value. But sine, as you can see, is beginning to round off. And hopefully you'll also be able to see that it's actually doing exactly a mirror version of what cosine did, coming away from 1. Keep going. Now cosine is really diving to the floor. It's going to hit 0 at 90. And sine is running out of steam. It's just got to 1. And there are the plots of the two complete curves. Sine climbing from 0 up to 1 and cosine decreasing from 1 to 0 between those same angles of 0 degrees and 90. Okay, let's wind ourselves back to 0 and add tan to the mix. Okay, right, I'm now moving the triangle. Here we go. And there's the blue line forming on the right. And it's following sine quite nicely at the moment. Now it's beginning to take off. It's heading towards 1 at 45 degrees. See if I can stop around 45 degrees. There we are. Well, just above. And it's confirming our result that we found earlier, that the tan of 45 degrees is 1. So now it's beyond the range of both sine and cosine. It will continue to climb. 1.4 there, and now it's off the scale. And is heading towards the highest number you can think of at 90 degrees. And it's disappeared out of sight. So there are the 3 completed plots between 0 and 90 degrees for sine theta, cosine theta, and tan theta. But of course the waves don't stop there, they continue on. I've altered the scale of things a little bit here because I want to show you what the waveforms look like as they go beyond 90 degrees. And I'm going to turn the hand right round from 3 o'clock all the way back round to 3 o'clock, going backwards, and we'll see the plots from 0 degrees up to 360 degrees. So here we go. The triangle forms. Sine and tangent copying each other really, but now tan's away. There's the 45 degree meeting point. Tan's now gone through 1 and heading north quickly. Sine and cosine. Sine reaching 1 and cosine reaching 0. Yes, cosine continues to fall and sine now is falling back towards 0. Tan's making another appearance. And I'll try to stop at 180. Roughly. So sine's come back down to 0, cosine has gone to -1. Tan has also come back to 0. Let's go on. This is just to show you the shapes. We're not going to do any maths with this. This is just to show you the shapes. Sine now is diving to -1, and cosine is coming up to 0. Tan's gone up to another infinity, as you can see. Continuing on. Cosine now starts climbing again. Sine's come back from -1, and guess what? It's heading towards 0 at 360 degrees. So they're going to end up with their same values that they started with at 0 degrees. Here we go. There are the complete waveforms for 0 to 360 degrees for all three functions. The red line is sine theta, the green cos theta, and the blue tan theta. And as you can see, tan theta is a very different animal compared with the other two. So have a look at them for a moment and make sure that you'll be able to reproduce them if such a question comes up in an exam.